In this short video, I will focus on using the binomial probability distribution function. P of x is equal to the combination of p times p to the power of x, 1 minus p to the power of n minus x. Now, this can be otherwise written replacing the combination with what it means, which is n factorial divided by x factorial over n minus x factorial. And then the rest is the same. So you see in the blue, I've rewritten I've written out the formula for the combination formula. And I'm going to use the example where n, which is the number of trials, is 10. P is the probability of success. And the question asks to compute the probability of x successes, where x is 4. So 4 successes in 10 independent trials of an experiment. So on the next step, we're going to simply plug in the 10, the 0.4, and the x, the values for n, p, and x. So when we plug it in, you see on the middle line what it would look like. Now on the very right, I've computed the 1 minus 0.4 and made that 0.6 with a simple calculator. So we have 0.6 to the power of 10 minus 4, which is 0.6 to the power of 6. And I've also computed in the denominator 10 minus 4 is 6. So there we have it simplified. And now I'm going to compute the part with the factorials. The 10 factorial divided by 4 factorial times 6 factorial. And I'm going to do this using a simple calculator, not a calculator with a factorial function. I'm leaving my 0.4 to the power of 4 and 0.6 to the power of 6 as they are for accuracy. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial on the bottom is 4 times 3 times 2 times 1. 6 factorial, which we're timesing the 4 factorial by, is 6 times 5 times 4 times 3 times 2 times 1. It's just by definition. Now, to compute this is not bad because we can cancel the 6 times 5 times 4 times 3 times 2 times 1 on the top in the numerator with the 6 times 5 times 4 times 3 times 2 times 1 in the denominator, because anything over itself is 1, so those cancel. And then on the bottom we have a 2 and a 4, and 2 times 4 is 8. That 8 can cancel with the 8 in the numerator position. And then we have the 3 in the denominator on the left. It cancels with the 9. 3 goes into 9 3 times. So all we're left with in the numerator is 10 times 3 times 7, which is 210. And 210 times 0.4 to the power of 4 times 0.6 to the power of 6 is 0.2502 to the nearest 4 decimal places, and that is our answer. That is the probability of 4 successes in 10 independent trials of this experiment.